Good morning, 8th grade. So let's go ahead and let's get started, guys, with our final lesson in this chapter. So this is going to be lesson 9-8, System of Linear and Quadratic Equations. And this is honestly, I know I've kind of said this a lot during the course of the year. I always say I have a favorite lesson, favorite chapter. This one's definitely in my top 5, and just because it's a lesson that really kind of makes a lot of sense, and if you follow the rules and you follow the patterns, you really shouldn't struggle with this, and this should be something that we all should do very well with. So let's go and let's get started with it. So system of linear and quadratic equations. So we're going to kind of be putting the two together. Remember, a linear equation, and this should be review. A linear equation is going to look like y equals mx plus b. And that's where x just kind of stands alone. And whenever we talk quadratic, that's going to be where we're going to have that x squared. So it's going to be that ax squared plus bx plus c. So that's kind of what separates, guys, linear and quadratic. So one has just a regular x, another one has an x squared. And we should know that a linear equation, that's going to produce a straight line. That's where I always think when I hear linear, I hear the word line, and those graphs are going to be very much just like it sounds. It's going to be a straight line on the xy axis. And then our quadratic equation, those are going to create the parabola. And that is just a curved line. Almost looks more like a U. So those are the two things that we're comparing and the two things that we're looking at. Now, with that being said, through this lesson, there's a couple different things you're going to see. And the first is in our system of equations where we have two solutions. And what that means is whenever I make a graph with a linear graph and a quadratic graph, those two are going to cross and pass through each other in two different spots. And you can see I've got my parabola drawn, and then I've got my linear graph that cuts straight through it, and the two intersect down here in the bottom left and also up here in the top right. So there's two spots where these graphs they interlock. 90% of the problems that you solve are going to be ones with two solutions in them, and they're going to look like this picture here. Now, the parabola might be flipped where maybe it's upside down, and then that line might be negative. But still, it crosses the parabola at two different spots, so therefore there would be two solutions. The next type of system that you're going to see is one that has one solution. And this is where the linear graph is going to pass the quadratic graph in just one spot. So they're going to meet just at one spot on the graph. And that's where the one solution comes into play. And that one solution, that's going to be your answer. Much like with the two solutions, there's two answers. And those answers, guys, those solutions, those are almost like ordered pairs. So that's like an X, Y ordered pair for those solutions. And then our last one is going to be a no solution. And you can probably already guess what that's going to represent. And a no solution just means that this linear equation and my quadratic equation, they're not going to meet. They're not going to intersect at all, and there's going to be no common points between the two of them. So if they don't share any of the same ordered pairs, then there's going to be no solution here. Let's go ahead and let's begin. So we've got, whenever we're solving the system of equations, there's three different ways that we can solve these. And in my opinion, guys, the first method that I'm going to show you is actually going to be the method that we use least. And I just want you to be familiar with it, and I want you to know kind of how to solve. And that first way is to solve by graphing. So what that means is I'm going to take my y equals and for my quadratic equation and my y equals for my linear equation. And I'm going to just simply graph those on an xy ordered pair or xy coordinate plane. And I'm going to find where they meet. And if I have two solutions, one solution, or no solutions. And then depending on how many solutions there are, I'm going to need to list those solutions off. So I'm going to begin by graphing this. And I'm going to graph the linear equation first. The y equals negative x plus 2. And all of us should know how to graph this, this graph right here. So at the end, I have my b. That's going to be 2. So I'm going to locate 2 on my y axis. So there's 2. Then I'm going to locate my slope. So my slope is negative 1. So I'm going to go down 1 and to the right 1. And that's going to put my next point here at 1, 1. And I could continue with that down 1, left 1, and just keep giving myself more and more points that are going to be on this graph here. So this one falls on the point 0, 2. It falls on 1, 1, and also on 2, 0. And I can go ahead and create that linear graph. So there you go. There's your linear graph. All right, so we've gone through and we've graphed our linear equation. Now it's time to graph our quadratic equation. And I know it's a quadratic equation because it has x squared. Now this might be a little bit review because it's been a while since we've graphed any quadratic equations. But remember guys, whenever we graph a quadratic equation, we want to find the vertex. And to find the vertex, we're going to use this formula to help us out. So to find my vertex, I'm going to use the formula x equals negative b divided by 2 times a. So let's go ahead and let's see if we can find what that x is in my vertex. So x equals negative, my b is negative 1. So I'm going to write negative 1 divided by 2 times a. And my a is also a 1 because there's no coefficient out here in front of my x, so I can assume that that is a 1. So now I'm going to go through here and I'm going to simplify. So x is equal to minus a negative. That's going to create a positive. So x is equal to 1 over 2. So x is equal to half. Then I want to find my y for my vertex, because remember guys, vertexes, that's your point. It's almost like if I look at this parabola above here, my vertex is that ordered pair that is the very bottom of my parabola. So I'm trying to find that ordered pair. So I've got an x, now I need to find a y. So I'm going to plug this half back into my equation and find out what y is equal to. So y is equal to 1/2 squared minus half minus 2. Go through, you solve your order of operations. So I'm going to first take half squared. That's going to give me 1/4. It's going to be 1/4 minus half minus 2. I go through and I subtract from left to right. So I have 0.25 minus 0.5 minus 2. Y is equal to negative 2.25. So my vertex is equal to the ordered pair 1/2 and negative 2.25. So I'm going to go ahead and I'm going to go over to my XY coordinate plane and I'm going to graph that vertex. So half and then negative 2.25. So there's my vertex. And then to find some other points that are going to fall on this graph, I can really just then kind of make either a chart, or I can move to the left and to the right by the same amount, and I can kind of go up by that same amount on each side. So for my vertex then I'm going to go through and kind of create a chart just to kind of make it easy and uniform for myself. So I'm going to go with -2, -1, 0, 1, 2, and I'm going to plug these values in for x to produce a y. And remember, we have that tool in our calculator that we can kind of go through and we can show it. So if we go up here to y equals, and then we type that in, so I have x squared minus x minus 2. I go to second graph, there's going to be my table. So I have some ordered pairs right there. So I've got -2, that's going to be -2, 4. I've got -1, 0. I've got 0, -2. I've got 1, -2. And I also have 2, 0. And it was a good idea, guys, that we found the vertex by hand, because the vertex is not, we can't see what that vertex is through the xy. I can't see what that actual point is through my table. So I've got my vertex, and it really kind of helps me whenever it comes time to graph this quadratic equation then. But this all could have also been found by hand if you didn't use your calculator. Again, just take these values and plug them in for your x, and they would have gave you these y values then. So x and y. I'm going to go through here on my coordinate plane, and I'm going to graph these points. So -2, 4, -1, 0. And if it helps, guys, to graph these in 2 different colors, by all means. If you want to use the same color, that works as well. Whatever works best for you. All right, so I've got my parabola, and I also have my linear equation. And there's one point that already sticks off, that already kind of sticks out. And again, I'm looking for how many solutions this is going to have. Well, by looking at my graph, I can already tell that one solution is going to be right here, kind of in the middle of my graph. And that's because my linear equation and my quadratic equation both cross at that same point. And that point happens to be 2, 0. So I know one of my solutions to this graph is going to be 2, 0. I also can tell that if I were to continue with this linear equation, it's going to run into my parabola. So I'm going to continue, guys, this line out, and I'm going to find what that extra point is. And without using my calculator, this can be very simple. We're just going this time up 1 and to the left 1. And this will work because we are still moving in the negative direction by going left. So I can go up to 3, over to -1. We can go up to 4, over to -2. So this graph is going to pass right through -2, 4. Both of my linear equation and my quadratic equation share that point. So -2, 4. So those are my 2 solutions for this graph. I have 2, 0 and -2, 4. You will never have, guys, more than 2 solutions on any of the graphs that we're doing in class today. So as my answer, I would just say this is 2 solutions, and I would write those as 2, 0 and -2, 4. Now, a couple reasons, guys, that this method is not my favorite one to use. And again, probably the one you're going to use the least amount, and that is because of kind of what you saw towards the end of this graph as we were making it. We almost had to kind of add on a little bit extra so we could find what that second point, that second solution is. So not really the most efficient and effective way of graphing. Also, whenever we typically make graphs on our own, it leads a little more to human error. So I kind of had to, as you noticed, correct this line a little bit so that way I could show that it went through this point. Also, whenever we're making our x, y axis, sometimes we don't make them where they're the most evenly spaced out. So again, this method does work. We can obviously see there's two solutions and where they're at, but again, because of us making the graph and it can be a little uneven sometimes, it's a little more difficult to visually see. Now let's move into kind of some of my more favorite ways of solving the system of equations. All right, guys, our next form is going to be through elimination. And elimination is just one other way of finding out if there is maybe no solution, two solutions, one solution, whatever it may be. And through this method, you don't have to graph. And I know graphing maybe isn't the most fun way of solving problems sometimes. So let's go ahead and let's get started with the elimination method. So with the elimination method, I have y equals 28x plus 4 and y equals negative x squared plus 39x plus 64. And whenever we eliminate, we want to, essentially, we're going to add or subtract these two equations together. And whenever we do such, we need to have one on top of the other. You always want to put the equation that has the x squared on top. So I'm going to rewrite these equations by having one over the other. So y equals negative x squared plus 39x plus 64. And I'm going to line it up with my second equation, the y equals 28x plus 4. And when doing so, I'm going to line up all the pieces as well. So the y's will get lined up, the x will get lined up, so 28x will be underneath 39x, and then plus 4 will be directly underneath 64. Now, through elimination, we are trying to eliminate either the x or the y. I'm really not too worried about the x squared because, again, we're doing one quadratic and one linear. So we're not going to have two x squares to begin with. You will always have a y because all of these are going to be y equals, and you'll always have an x in your equations as well. So I'm going to try to eliminate or get rid of one of my x's or my y's. Doesn't matter which one. Now, with that being said, in order to eliminate them, I need their coefficient to be the same. So 39 and 28. Those two are not the same, so I can't eliminate an x. My coefficient with my y's, those are the same. They have nothing in front of them. That's almost like a 1. And so those both have the exact same coefficient. So I can eliminate my y. So I'm going to either add or subtract these two equations, whichever way gets rid of the y's completely. If I were to add these two equations together, and I had y plus y, that's going to give me 2y. That does not get rid of the y. What if I did y minus y? Well, it'd be the same thing as doing maybe 1 minus 1. That's going to give me 0. So that is going to eliminate my y altogether. And that's my goal here with elimination. My first step, guys, when I solve these is I want the y's to become a 0 or I want the x to become a 0. Now, you probably heard me say that we could either add or subtract these equations. And maybe you're thinking ahead, well, Mr. Garrett, when would I ever add? Because you're going to always subtract things to get 0. Well, what if I had negative y, and y. And I wanted to eliminate those. Well, their number that's out in front, that coefficient, is still the same. They both have a coefficient of 1. It just happens that one has a positive 1 and one has a negative 1. And if I want to eliminate those, I would not subtract them. And we can see that because negative 1 minus 1 gives me negative 2. But if I add those two y's together, so negative 1 plus 1, that gives me 0. And that would make those y's be eliminated. They would almost kind of cancel one another out. So my goal, guys, is to get these to cancel. It doesn't matter if that coefficient, one's positive, one's negative. I just need them to be the same number. So 1, negative 1, 1, 1, negative 1, negative 1. So I want them to be the same. It could be negative 5,000 and 5,000, but I just need them to be the same. Let's go on, let's continue on with this problem. So I went through and I've subtracted my y's, they canceled out. Now let's go through and let's subtract the rest of these two equations. So now I have negative x squared minus, well, if it helps, add a 0 down below. So that way you're actually doing something with that negative x squared. So if I do negative x squared minus 0, it's going to be like doing negative 1 minus 0. You're going to get the exact same number. So it's just going to be negative x squared. Then I go through and I complete the rest of these. So 39 minus 28, that's going to give me 11. So plus 11x. And the final one is going to be 64 minus 4. And that's going to give me positive 60. So I now have negative x squared plus 11x plus 60. I've got this quadratic equation now that does not have a y in it. It only has an x. From here, I want to now factor. I want to factor this into two sets or two quantities that whenever we FOIL them are going to give me this negative x squared plus 11x plus 60. So whenever we break this down, I can pull out, I know that I can pull out a negative because there is a common theme here, and I want to try and get this x squared to become positive. So I can pull out a negative from this x squared plus 11x plus 60. So from there, I'm now trying to FOIL x squared minus 11x minus 60. And the reason I got this equation, again, was because we pulled out the greatest common factor, which was a negative 1. It's going to make it a lot easier on us, guys, if this leading term is positive. So now I'm looking for what two things, when multiplied, are going to give me an x squared. And I know that's going to have to be an x and an x. Now I'm looking for, okay, what two numbers, when multiplied, give me negative 60, however, when they're added together, give me negative 11. Well, I know that the only way to get a negative, guys, is with a positive and a negative, because a positive number times a negative number is negative. So what two numbers can I multiply together to give me 60 and then add together to give me negative 11? And that's actually going to be 15 and 4. Now, do I want the 15 to be negative or positive? I want 15 to be negative because I have negative 11. So it's going to be x plus 4 and x minus 15. So I have now just factored my polynomial here. Now I need to find out, okay, what does this x equal? So I'm going to set each one of these equal to 0. So I'm going to have x plus 4 equals 0. And I'm also going to have x minus 15 equals 0. From there, I solve for x. So I'm going to subtract 4. So x is equal to negative 4. And on the right side, I'm going to add 15. So x is equal to 15. Now remember, guys, with these problems, we were going to have either no solution, one solution, or two solutions. And if we had two solutions, we needed two ordered pairs. So I really do need two x's if I'm going to have two ordered pairs. So this is already kind of lining up like I'm going to have two solutions, with the first one being a negative 4 for the x, the second one being a 15 for the x. Now to finish out these ordered pairs, since I've got the x value, I just need the y value. To find the y, I'm just going to take my x, plug it back into one of the equations, solve, and it's going to come out with the y. It really doesn't matter which equation you plug it into, you're going to get the same answer regardless. I'm going to choose this first equation because the first equation is a lot simpler because it's linear and I don't have an x squared. So I'm going to work with the equation y equals 28x plus 4. So I'm going to plug this negative 4 into my linear equation, find that y, and then I'm going to plug this 15 in for x in the linear equation, and that's also going to give me a y. So let's go ahead and let's get started here. So y equals 28 times negative 4 plus 4. I go through and I solve. Y is going to be equal to negative 108. So I know that one of my solutions to this problem is the ordered pair negative 4, negative 108. So there we go. There's one of my solutions. Let's see if we can find what the second solution would be. Again, I'm just going to take this equation, and everywhere that I see an x, I'm going to plug in a 15. So I plug it in, I do 28 times 15. I add 4. Y is equal to 424. So here's my second solution. X equals 15. Y equals 424. So there you go. We've got both of our solutions. So this would be a problem that has two solutions. Here's the first, and here's the second. And this is why we don't graph, guys, because I really don't want to have to create a graph. It's going to go all the way up to 424 because that graph is going to stretch on forever. So again, elimination. I'm setting them up where I'm adding and subtracting, adding or subtracting my two equations. Remember, your quadratic one always goes on top. Once I finish adding or subtracting, I should have canceled out one of my variables. It does not matter if it's the x or the y, but I want to cancel one of them out. From there, I factor my quadratic expression or equation here, set both of those equal to 0, find my x, plug it back in, find my y. And there you go. I've got an x and a y. I've got an x and a y. I've got two ordered pairs. So there are my two solutions. Let's look at maybe a second way of solving these, and this is by substitution. Guys, with this problem and even the one above, you could use elimination or substitution and still get the same answer. That's kind of the nice thing about these as well. You can use either method to find the answers to these. So with the second one, I have the two equations. I have y equals x squared minus 6x plus 10. And I also have the equation y equals 4 minus x. Whenever we solve through substitution, we're doing exactly like it says. We are just substituting in for one of the variables. So whenever I substitute, I want to get one of my equations where it's y equals or x equals. And the nice thing with where we're at in algebra right now is almost all of these that you saw are going to already be y equals. So I can go ahead and substitute kind of from the get-go. I'm going to substitute my second equation into my first. So I'm going to put 4 minus x, because it's equal to y, I'm going to put it and substitute it in for the y up top. So by doing so, 4 minus x is equal to x squared minus 6x plus 10. All I did is I plugged 4 minus x in for y in the first equation. I just substituted it in. From there, I want to combine like terms, so I'm going to add x to the other side. So I have 4 equals x squared minus 5x plus 10, and then I'm going to subtract 4 over to the other side as well. So I'm going to end up with 0 is equal to x squared minus 5x plus 6. And now with guys where we're at, it's very similar to where we were with elimination. This method was maybe a little quicker. It just kind of depends, guys, the problem that's given. But I think elimination and substitution move a lot faster than graphing. So now from here, I've got x squared minus 5x plus 6. I'm going to go through and I'm going to factor again, just like we did with elimination. And I want to factor into two quantities that, when FOILed, will equal x squared minus 5x plus 6. So when I FOIL, I know that x squared breaks down into x and x. I'm going to be equaling a positive. However, when I add the two together, it's going to equal a negative. So I know I'm going to have a negative and a negative. What two numbers, when multiplied, give me 6, added together, give me negative 5. That's going to be x minus 3 and x minus 2. From there, just like we did above, set each of these equal to 0. So x minus 3 equals 0, and x minus 2 equals 0. Let's go ahead and let's solve. X is going to be equal to 3. X is going to be equal to 2. When I solved, I just added 3 and added 2 to the other side. So I've already found my x now for both ordered pairs. And to finish this one off, I'm going to plug x back into the original equation. Again, it doesn't matter which one. If you want to plug it into this x squared minus 6x plus 10, go right ahead. You'll get the same answer I'm going to get. However, I'm going to make it really simple on myself. Plug the 3 into the linear equation. Do 4 minus 3. I know what 4 minus 3 is. Y is equal to 1. So my first ordered pair is going to be 3, 1. Next up, I have a 2, so I'm going to plug a 2 in for x. 4 minus 2, I know what that is. 4 minus 2 is 2, so I know that my next ordered pair is going to be x equals 2, y equals 2. That creates the ordered pair 2, 2. And there you have it, guys. Those are going to be the two solutions for this system of equations. Like I said, majority of the ones you solve, they're going to be two solutions. Here's how you know, guys, if you have a no solution. If you have a no solution, once you solve and you maybe plug something in, you would have, for example, 7 is equal to 0. So if you ever find that something is not equal to something, then that's going to mean that you have no solution. If it's no solution, you're going to end up with something like this for both of these, because there's no solution the first time you go through, there's no solution the second time you go through and solve. If it were one solution, you're going to get something like this for just one of them. And then the second ordered pair is going to come out to be an actual ordered pair. So just kind of be mindful of that and kind of keep your eye out for it as we go along, okay? All right, last thing that I want to talk about, and I'll be kind of quick with this, is on your calculator. You can also solve these through it. Now, after I show you this, that doesn't mean that you need to be using your calculator to solve every single one of these problems. I know I'm not there watching you, but again, you're going to get absolutely nothing out of this lesson if you're relying on your calculator to solve every single one of these. So let's go through our calculator and let's kind of take a look at how to do this. So if I go to my calculator, I'm going to go to that y equals screen. I'm going to type in my first y equals the first y equal that I'm seeing. So negative x plus 5. Next y equals, I'm going to type in the second equation that I have. So negative x squared plus 4x plus 1. From there, I'm going to hit graph. When you hit graph, see if I can get rid of that glare. It's a little better. From there, whenever I hit graph, you can see my parabola and you can also see my linear equation. So I've got both of them showing. I know this one is two solutions, and that's because my first solution is right here. My second solution is right here. I know that my linear equation passes through my parabola in two different spots. Maybe I want to find out, okay, what are those two solutions going to be? If I go to my calculator and I hit second and this button that says trace, I can arrow down to number 5 where it says intersect. And it's going to ask me my first curve. What that means is it's asking what is your first line. And I want to pick something that's to the left of where these two intersect. And my little dot that's flashing is to the left, so that's a good spot. Now my second curve, it's going to look at your second line. And this is all based on how you type these into your calculator. So this was the second line that we typed into our calculator. I want to also make sure that this one is on the left of this dot, which it is. It's blinking just to the left of it, so I know that one works. I hit enter again. It's going to come up with guess. You can kind of turn this into a game if you want. Maybe you're real competitive and you want to try and guess what this is going to be. So I can arrow up and I'll put my dot right here. I'll guess that it's about there. I hit enter again. It's going to come out with the actual intersection. So those two are going to intersect at that 1, 4. So your first ordered pair is 1, 4. So there's your first solution. To find your second solution, you do the exact same thing. So I'm going to hit second, trace. I'm going to go down to intersect. And then from there, I want my first curve. This time, guys, I'm going to do it to the right of that dot because I want to make sure that it's focusing on the dot that's closest to this right side over here. So I'm going to hit enter. I want to make sure that my second curve is also to the right, which it is. Hit enter again. Again, you can guess if you want. You don't have to. You can skip this by hitting enter. And there you go. There's your intersection. So this new intersection is at 4, 1. So my two solutions are 1, 4 and 4, 1. So there you have it. You've got a couple ways, guys, of solving all these. You can graph, you can use elimination, you can use substitution, or you can use your calculator. This needs to be the last step that you do, or the last method that you do, guys. Elimination, substitution, you need to know how to do. Don't rely on your calculator. Hopefully you guys enjoyed the video. If you are confused on anything, if you have any questions on anything, please let me know and reach out. Going to give a quick shout out. Hopefully you can see him on my camera here. There's my dog. Jeter, you awake? All right, I guess he's not awake. All right. See you guys. Hopefully everybody has a good day. Bye.